So using our new late rule, when we look at this and I see my product is x squared being multiplied by sine 3x dx, the x squared will be my algebraic piece. So u will be x squared. That means when I go to take the derivative of u in terms of x, I get 2x. And for my rule, I need to rearrange. So du is 2x dx. And then that means the other part is my dv is equal to sine 3x dx. And when I take the antiderivative of this, I would get negative 1/3 cos 3x. Okay, so you just have to remember which way you're going. So this is derivative, this is antiderivative. All right, so from here, I can now fill in my formula with some more paper I need. Okay, so step 2, the rule says u dv is equal to uv minus the integral of v du. So I am going to write this out as x squared sine 3x dx is equal to, I said u was x squared, and then the antiderivative of sine 3x is negative 1/3 cos 3x minus what I'm going to have to integrate next, which is v, which is negative 1/3. Sorry, I lost myself on my paper. Cos 3x multiplied by du, which happens to be 2x dx. So here brings in a little more complication. So let's just tidy this up before we try to do more with this. So this is equal to negative 1/3 x squared cos 3x. Then I've got two negatives when I pull out that 1/3. So I'm going to put a plus here. The 1/3 and the 2 could go together to 2/3. So that's the constant. However, when I look inside, I still have an x and a cos 3x. Ew. An x and a cos 3x dx. Well, here introduces a second product. We're not done. So to integrate this, we have another product. What does that mean? It means you have to do the whole process again. Okay, so you have to do integration by parts again. So this brings in a third step. Okay, we're not going to be done. We have to assign another uv dv piece. Okay, sorry. So in this case, late again would say u is x, du, dx is 1. And so then du is just dx. And then the new dv, when we go back and have a quick look, that's cos 3x dx. So you're still using your late rule on this. And then the antiderivative of that is negative 1/3 sine 3x. Sorry, positive. Whew. Okay, so maybe you're saying, hey, Malmstrom, we did this already. We did this. This was example 2. So we can cheat a little bit on this question because we already know the answer to this. From example number 2, we have the answer. Maybe it would help if I put my paper on the left. I'm having a hard time reading my notes today. Okay, so we already know the answer to this is, okay, from number 3, the answer was 1/3 x sine 3x plus 1/9 cos 3x. That's by putting it all back into that rule from example number 2, way back here. Okay, so we already did the hard work in 2, and now we need to use that piece right here. So we're going to have to multiply it by the 2/3 and then not forget the front part in this particular question. Okay, so let's try and put this all together now. So this will be kind of like step 4. We have that we were looking at x squared sine 3x, the integral of this, is equal to, so we still have our uv from the original work in step 2, negative 1/3 x squared cos 3x plus 2/3 times this whole piece. So let's put that in, 1/3 x sine 3x plus 1/9 cos 3x. All right. It just needs a little bit more space. Let's tidy this up. So this would be negative 1/3 x squared cos 3x. Put some brackets on that. Plus distribute the 2/3. So I have 2/9 x sine 3x plus 2/27 cos 3x plus c. Don't forget your plus c, because you go through all of this work and you have to do integration by parts twice. And then please don't forget your plus c on the very end of this. It's a lot of work to get through this. Okay. Example number 4. If you're feeling confident and you want to give this a little bit of a try on your own, then feel free to pause and give example 4 a try on its own. It does have ln x in it, but you know the pieces of it from the beginning of the lesson. It's not in your notes, but just scroll back and you'll see it there. Okay, so by late, who has to be first? Oh, okay, it looks like ln has to go first because of the L logarithmic. So u, this time around, is going to be ln x. du dx. So the derivative of ln x is 1 on x, and you can get that from the beginning of the notes or your formula sheet, if you still have your formula sheet. Then we're going to manipulate this so that we have du isolated. So we will get that this is dx on x. All right, and then that means that the algebraic piece actually comes from x squared and the dx together. So that's representing your dv. Algebraic comes second, yes? Okay, so we have x squared dx. Now you have to remember we're actually having to take the integral of that to find our v. So what is the antiderivative? Add 1 to the exponent and divide by that. So we have 1/3 x cubed. It's really important. I can't stress enough. You need to know which way you're going. Okay, derivative, antiderivative. All right, there it is. You got our 4 parts. Now we're going to use our rule. I like to write it out so that I know that I'm not missing anything. So I just always write it out. So the integral of u dv is equal to uv minus the integral of v du. And then it's not a bad idea to always write out the beginning part. So we have x squared ln x dx is equal to u, which was ln x, being multiplied by v, which is 1/3 x cubed, minus the part that we still have to integrate, which is v which is, what did we say was z? 1/3 x cubed. I just wrote it out. I don't know, must need more coffee. And then our du is dx on x. Whew. Okay, let's tidy this up before we try and do more with it. So we have that this is equal to 1/3 x cubed ln x. That just looks prettier. Minus, we're going to put that 1/3 in the front. And then I can see that I can actually cancel that x and make that become an x squared. So let's do that, x squared dx. And then that's a fairly easy antiderivative to take. So this is equal to 1/3 x cubed ln x minus 1/3 times the antiderivative of x squared, which is 1/3 x cubed, plus c. And then we just tidy that answer up. So we get 1/3 x cubed ln x minus 1/9 x cubed plus c. Voila! What happens if they ask you for a definite integral? Could we still do this? Could we do this question by integration by parts? And you're like, Malmstrom, this just looks weird. Okay, so here's a thought. What if I said my product was ln x dx? Then by late, we would still have a ln, so that has to be my u. And we just did this in the previous question. So the derivative of that is 1 on x. And then what do we have? Du is equal to dx on x. And then the second part is just weird because we're going to say that dv is equal to dx. Well, it's really equal to 1 times dx. So think about what the antiderivative of 1 is. It's x. So that gives v as being x. Okay, so let's see. If we put this into our rule, u dv is equal to uv minus the integral of v du. So we have that ln x dx, and this is a definite integral, so we could actually put in our boundaries from 1 to e, is equal to u is ln x, v is x, minus the integral of x dx on x. Oh, that's cool. Look at that. Those just cancel out. Coolio for us. All right. So we have that this is equal to x ln x. Let's put our boundaries on this. Being evaluated. Oh, we are going to take the antiderivative of dx. Well, what's the antiderivative of 1 dx? It's 1. So minus the antiderivative of x. Sorry, the antiderivative of 1 is x. I'm getting myself messed up. This should be x. My bad. All right. And then we have to evaluate this from 1 to e. All right, so we have that this is equal to e ln e minus e, subtract 1 ln 1 minus 1. That looks a little weird. Okay, so here's a little funky little note. Ln x is equal to log x base e. So ln e is equal to log e base e. Well, as long as those two things match, then the answer to that is equal to 1. So that is only equal to 1. So now I have e minus e, doesn't matter what e is, if you're subtracting them, that's going to be 0, is equal to ln 1, because anything times 1 is 1, minus 1. Oh, sugar. Minus. Okay. And what does that leave me with? So let's think about log e of 1. So this, doesn't matter what this base is going to be 0, right? So ln 1 is 0. You can put it in your calculator. So what do I got? 0 minus